Okay, so there's some general questions about workflow management languages, which I think are interesting to dig into. It'd be nice to have some participation from those of you on the chat, actually. So Kurt is asking, what are the options for workflow management languages to learn, and which one do you recommend? Are there any good ways to learn that you'd recommend, or is it best just to leap in and learn as you use it? So lots of questions there. Over the last few years, there's been a very large number of workflow managers being developed. But I would think at this point, the community is going through a kind of process of standardization on one or a couple. And I would say at this point, Nextflow seems to be above, by far the most popular workflow manager that people are using. And of course, there's that kind of effect you get when, if a lot of people are using a thing, it encourages more people into the community. And as a result, Nextflow has a huge number of available pipelines that can be reused. And Nextflow themselves, the organization, have a set of curated pipelines in a project called NF Core. And there's a huge number of bioinformatics pipelines, including those for SARS-CoV-2. So there are alternative pipelines for analyzing Arctic data in there as well, which I haven't used, but look to be pretty good. I think the only other workflow manager that I still see people writing and developing against is SnakeMake, and that seems to be popular for those that are really into Python. So SnakeMake is effectively a workflow is written in Python, and so if you're adept with Python, then people might prefer that. It's just a slightly different way of working to Nextflow, but Nextflow does seem to be dominating at this point. Nextflow uses a language which is not particularly common, called Groovy, which is a little bit like Java, and I think newcomers find it a little bit difficult sometimes to get into, but once they have, they tend to like it. Oh, Andrew has got his hand up. Andrew, did you want to comment on that?
Yeah, I'd just like to give a shout out for Galaxy. Hopefully you can hear me. And Galaxy, if you don't want to do the command line route, you can take some Galaxy pre-made pipelines, and also you can make them interactively on Galaxy websites. And there's a lot of work has been done on that.
Yeah, thank you. Yeah, Galaxy, obviously, it's not so much a workflow language, but more of a interactive website for running pipelines. And certainly one of its major selling points is kind of ease of use, I suppose, and accessibility. In terms of like good ways to learn, I would say, like all bioinformatics, it probably is just best to try and leap in and try and do something. And I think it's a very common pattern in bioinformatics that if you have a task you wish to automate, something that perhaps you're doing manually. I used to run the Arctic pipeline one at a time per sample. Of course, that gets very boring very quickly, and it's a simple thing to do is to try and write a way of automating a pipeline to just run the same command multiple times on multiple samples. That's probably how most people will learn. I suppose the other way of learning is to take a pipeline that already exists, that pretty much does what you want, and try and modify it to maybe add a feature that you need or change it in some way to work with your local environment. So those are probably the two ways to learn. I'm pretty sure if you Google Nextflow on YouTube, there'll be a bunch of tutorial videos, but I haven't really looked into that. Okay, yes, okay. So I'll just answer that question of Kurt's as well, follow-up question. Is Miniconda an example of a workflow language? There's no stupid questions, Kurt. Miniconda and Conda and BioConda are all part of the Conda family. And Conda is effectively a running environment. It's a package manager and a running environment. So it's not the same as Nextflow or SnakeMake or workflow language. It's a way of providing an environment that your software can run in. So the Arctic pipeline, the Nextflow pipeline that Matt mentioned, can all be easily run within a Conda environment. So a Conda environment typically is a way of specifying all of the dependencies, the requirements that a pipeline might have. So let's say the Arctic pipeline relies on Minimap to align reads, and it relies on nanopolish to call variants. So when you create your Conda environment, all of those dependencies, those requirements are installed at the same time. And it's quite a nice way of ensuring that your environment is consistent. So you have just the packages you need and the correct versions of them. So that's what Conda does. Other ways of doing a similar thing would be through containers. You might have heard of Docker and Singularity. That's a slightly different way of doing this, having the same idea of a consistent environment. Okay, so we're running out of time, but let's try and answer a couple of questions there. So Phil was asking about the ability to do typing through the ARTIC-NF workflow. Matt Ball developed a piece of software called Align to Type, which uses variant definitions that are developed by PHE, and I think that is a feature in the workflow. I'm afraid you probably have to dig around the GitHub. It looked like there was an issue about, it was a commit in there, number 83, I saw, that introduced that functionality. But in terms of how you run it, you'll have to look around the GitHub for that. On tomorrow's talks, we'll have talks from Anya and Verity, who will talk about Pangolin, and we'll also mention their new software, Scorpio, which does a similar thing, which is another way of doing variant typing. So there will be some stuff about variant typing tomorrow. Ricardo asks a question, which is it possible to accurately identify co-infection within a host of 2 or more lineages? Well, that's a good question. I guess I'll answer that in the context of the 2 talks that have just been. The software will try and identify mixed bases. You know, if you've got a mixture of bases at a position, those will be encoded by the pipeline either with N characters or with IUPAC ambiguous characters, i.e. it will say, you know, this position is either an A or a T or either a G or a C, not sure. And so you can use the output of those pipelines to try and flag up samples that might be a result of a co-infection. So if you see a large percentage of mixed bases, assuming that's not a problem in the lab, contamination or whatnot, you might have a co-infection. But if you want to then go and look in detail, you're going to have to do your own type of analysis to look at that. You're going to have to go and look at the BAM files. You might have to run your own variant caller. Some people use software called LowFreq as a way of looking at in more detail at lower frequency variants in a sample. It's probably easier done with Illumina data than ONT data, but it can be done with ONT data if you work hard at it. So the software itself won't tell you it's a co-infection, but it will give you some indicators that you have mixed bases, which might be indicative of co-infection. But I'm not aware of any packages that kind of give you all of the co-infection information. Having said that, Chris Quince will be talking about how to look at wastewater, which is effectively a mixed infection in the environment. So you might have to be relevant. Okay.
Sorry, I would just caution that in probably most cases, you don't have a co-infection. It's probably just lab contamination, you know, in probably 99.9% of cases.
I would agree with you, Andrew, that contamination, in my experience, is much more common than co-infections, but you do see them. You do see them at times. You know, but I think that the frequency of them is actually quite low, or at least the detectable frequency of them is really quite low. Miguel's asking, can you use Anaphor and Arctic data to assess intrapatient evolution in any detail? You can, but again, it relies on the fact that you're going to need those. Yes, you can for intrapatient evolution. You can look at low frequency variants. We did a paper on this using Arctic type data for Zika to see at what allele frequencies you could reliably use Nanophore data. And as long as the allele frequency is above about 10%, you can quite reliably track subfractions of allele frequencies over time. So you can use Nanophore data. I would probably prefer to use Illumina data if I had the choice, but you can certainly have a go at using Nanophore data. works better if you have specific mutations you want to track, rather than saying, tell me about all of the variation in the sample, because at a certain allele frequency, it can be hard to distinguish what's genuine variation in the sample and what's noise from the sequencing. And remember, the nanopore error rate is still around 3–4%. So, you know, you're not going to be able to easily find low frequency variance at 1% and confidently distinguish that from sequencing error. So you probably need a higher threshold, like 10%. With Illumina data, you can probably go a bit lower than that. But you can use Amplicon data in that way. It is possible, but there are various caveats. I'll post a paper in that talks about that in the chat in a minute. Last question, I think, because we're 10 minutes over time, from Kurt. Maybe Andrew might want to take this one. Can anyone recommend a good resource about what is a workflow language and what is an environment for bench scientists and rusty bioinformaticians? I feel like a rusty bioinformatician these days. Andrew, have you got any suggestions? I would guess the microbinky podcast is a good place, actually. I'm sure you must have covered that.
I probably, yeah. I suppose that's more introductory kind of stuff. So the Welcome to Advanced courses do occasionally run courses on, you know, introductory to pathogen genomics, and that might be a good place to start. But it's more on the basic level, I think, like basic computing skills.
Okay. So not okay. I mean, I think yeah, Google is a good place to start on that. I think the Nextflow website is actually very good, so I would definitely have a look around there. In terms of using Conda, I mean, you're going to learn some of this in the homework. So if you want to play with Conda, we have some of that in. We have a how to run the Arctic pipeline as homework, so you could have a go at trying to do that. I would certainly encourage to just give it a try. Conda will work on Linux, it will work on Mac, and it will work on Windows if you use the Linux subsystem for Windows, WSL2, or if you install a virtual machine on your Windows machine. So there are two ways of doing that. So you can certainly give it a go.